All right, today I'm going to show you how to summarize the lab. Now normally I don't do this because I like you to try and discover it on your own, but because of virtual learning it's going to be pretty much impossible. So I'm going to give you a lot of guidance today. We're going to start with where we're supposed to end up, the equation for centripetal force. So Fc equals mv squared over r. If I rearrange that equation algebraically and solve for v squared, I end up with FCR divided by m. This tells me that v squared should be proportional to f, v squared should be proportional to r, and v squared should be proportional to 1 over m. So then we set up our lab in such a way that we can test those variables. So our first variable, v versus force. When we plotted the graph, we should have got something that looked like this, a side opening parabola. A side opening parabola tells us that we have a square root function. But instead of plotting the square root of f, I went ahead and plotted v squared versus f. So then I get my equation y equals mx plus b, but in this case it's going to be v squared equals some constant, the slope of our line, times f. But we know because of our proportionality that that constant should be related to r over m. So if we take our data and we divide r by m, it should equal the slope of our v squared versus f. And we can go ahead and find our percent error at that time. Do the same thing again. V versus r. Now our variable r, plotted it out, v, r. Again, we get a side opening parabola, saying it's a square root function. Square the y-axis, v squared versus r, we get a straight line. Y equals mx plus b, where we get a constant again for our slope. But this time we know our constant is equal to f over m. So we should be able to go ahead, find our percent error of f versus m. And our last one. Our last one is v versus m. This one's a little different. It's a little more complicated because our proportionality for m is an inverse and a square root function. So we have both the square root and the inverse function going on. So when we plotted our graph, we probably ended up with something like this. And then if we square the y-axis and take the inverse of the x-axis, we should get v squared equals k times 1 over m for our equation. Y equals mx plus b. No b. We're getting rid of the b every time we're here, right? So k now, because of our proportionality, should equal f times r, and we can go ahead and find our percent error for that one. If you still have questions after this, go ahead and email me and we'll see if we can work it out. But you should be able to try and manipulate your data. If we do not get reasonable percent errors, we should try it again before we pass the equipment on to the next group. All right, thank you very much.